In question 5a, we are presented with various voltages and asked to determine the logic levels when they are applied to different logic devices. To answer this, we need to look at the electrical characteristic of these devices. The first device is 74LS00. This device belongs to the 74LS series. Here we are interested at two input voltage parameters, namely VIH min and VIL max. VIH min represents the minimum voltage at the input to be considered high, while VIL max represents the maximum voltage at the input to be considered low. The manufacturer of the device guarantees that when the voltage supplied at the input is equal or higher than VIH min, it will be considered as high, and when it is equal or less than VIL max, it will be considered as low. Any voltage level falls between these two thresholds, its logic will be undetermined. That means that the manufacturer will not guarantee whether the logic is high or low. So 0.8 volt at the input of 74LS00 will be considered logic low because it is not greater than VIL max of the 74LS series. 1.2 volt will be undetermined because it is in between VIH and VIL. The logic is neither high or low. 2.7 volt certainly makes a logic high, as it is well above VIH minimum. The same for 3.5 volt. For 74HC00, 0.8 volt at the input will also be considered as a logic low because it is less than VIL max of the 74HC series. While the logic is determined for 1.2 volt at the input of 7400, it is considered as logic low for 74HC00 because the voltage level is lower than VIL max of 74HC series. The logic of 2.7 volt will be considered undetermined because the voltage level is in between VIH max and VIH min and VIL max. Lastly, 3.5 volt will be considered logic high as it is equal to VIH minimum.